So the next thing we need to talk about is the chain rule. This is going to be another one of our derivative rules. So when we have two functions, so when we have a function that is a composite of two or more functions, by composite function I mean f of g of x, we need to use all the techniques we've already learned to differentiate it. We could. However, that would make our function break down and it would get really cumbersome. So we have a shortcut, and that is the chain rule. So the chain rule says if I have two composite functions, the derivative of the composite functions would be the derivative of the outside function times the inside function times the derivative of the inside function. So how does this work? So let's take a look here. Let's rename this h of x. That means my f of x, the outside function, is really just this cube here. And my g of x, my inside function, is 4x minus 2. So what I'm going to do is I'm going to take the derivative of f of x, so h prime of x is the derivative of f of x of g of x times g prime of x. So I'm going to take the derivative of f of x, which is 3x squared. So that gives me 3 g of x squared times the derivative of g of x, which is 4x minus 2. So g prime of x is just 4. I'm going to go ahead and write f of x for you, which is 3x squared, times g prime of x, which is just 4. So now I have h prime of x equals, let's combine like terms, 4 times 4x minus 2, we're substituting g of x back in, squared. All right, let's take a look at this next example. So I need to rewrite this, right? This is really h of x, and I want to rewrite this not as a fraction, right? So this would be 4x squared plus 1 to the negative 3. Remembering that the rule for exponents, if I have x to the negative 4, that becomes 1 over x to the 4th, because we typically don't want to work with negative exponents. But now it's going to make our life easier. So that means my f of x is x to the negative 3, and g of x is 4x squared plus 1. I'm going to go ahead and take the derivative of both of these. So f prime of x becomes negative 3x to the negative 4th, and g of x, g prime of x, becomes 8x, because we take 2 times 4, keep the x, and then that constant goes away to 0. So now my derivative of h of x is going to be negative 3 to the negative 4th of g of x times g of x, which the derivative of g of x, which is 8x. So I have h prime of x equals negative 24x times 4x squared minus 1 to the negative 4th. Now let's go ahead and rewrite that as a fraction. So h prime of x equals negative 24x over 4x squared minus 1 to the 4th. Okay, another example. Here, my f of x, that outside function, is x to the 4th, and my g of x, that inside function, is 2x to the 4th plus 2x minus 1. So my derivative of h of x, which I just am calling h because it allows us to keep the notation correct, but calling it anything would be fine. So I've got h prime of x, which is going to be the derivative of this, so 4 my g of x cubed And then the derivative of this, which is going to be 8x cubed, 8x cubed plus 2. So that's how we use the chain rule. Now what if I have sine 3 to the cube of x cubed? Okay, we can rewrite this as sine of x cubed. So again, my outside function is just x cubed, and my inside function is sine. Now we're using a trig function, and the derivative of sine is cosine. Wonderful. So the derivative of h of x equals 3 sine of x squared times cosine of x. Let's try this again. Now my outside function is sine and my inside function is cosine. So to take the derivative of this function, I'm going to take the derivative of sine, which is cosine of my inside, cosine of x, times the derivative of cosine, which is negative sine of x. So we can go ahead and distribute that negative, because that's what we like to do. I have negative cosine of x, sine x. Next, my outside function is cosine, and my inside function would be 5x squared. So the derivative of this would be the derivative of cosine, which is negative sine of my inside function, and the derivative of my inside function, which is 10x. So I'm going to rewrite this as negative 10x sine of 5x squared. So here are our steps for applying the chain rule. Identify our two functions. We already did this. Find the derivative of our outside function evaluated at g of x to obtain our first term, and then multiply that by g of x. Note that when we're applying the chain rule to two or more functions, we work our way from the outside in. So f of x equals secant of 4x to the fifth plus 2x. The derivative of secant is secant of x tan of x. So we're going to have to make sure to evaluate secant at our function and tan at our function. We then want to multiply that by the derivative of our inside function, which is going to be, we're multiplying here, which is going to be 4x, 4 times 4 is 16, x cubed plus 2. Next, I have the derivative of sine of 7x plus 2, f prime of x equals cosine of 7x plus 2, and we're going to have the derivative of this function, which is 7, so we'll throw that in the front, because that's what we like to do with constants. Next, I have the derivative of f of x equals 2x plus 1 to the fifth times 3x minus 2 to the 7th. Okay, so here I have to take the derivative of both of these parts using the product rule, right? So f prime of x equals the derivative of our first function times the derivative of, plus the derivative of our second function. And now I use the chain rule for each of these pieces. So here I have f prime of x equals, we'll take the derivative of our first function, which is going to be 5, 2x plus 1 to the fourth times 2, plus 7, 3x minus 2 to the 6, and the derivative of the inside is going to be 3. So now the derivative of my function is 5 times 2, so I've got 10. 2x plus 1 to the 4th, plus 7 times 3, 21. 3x minus 2 to the 6th. All right, now let's take a look at one more example. I have f of x equals negative 2 times 5x plus 7. Let's take a look at this. Now, for this, it may look like a composite function, right? But let me show you what's going to happen. So my f of x in this case, the outside function, is going to be negative 2x. That just goes away to negative 2 if I take its derivative. And g of x goes away to 5. So let's see if this would even work. We're experimenting here. So I have h of x is negative 2 plus 5x plus, times times 5. So I'd get negative 10. What if we'd gone ahead and distributed that? That would give me, my function was negative 10x plus 7. If I took the derivative of this, I get negative 10. So it works either way. I think this way is a little bit easier, this first way we did it, because you don't want to use the chain rule more than you have to, because it can have lots and lots of steps.